Welcome to EEL 6509 course project presentation. My project title is Performance Comparison Between Different Modulation Methods. My name is Ding Yuan. Here's the introduction part. The global system for mobile communications is a wireless telecommunications standard for digital cellular service. It is the most popular standard for mobile phones in the worldwide and has more than 3 billion subscribers. The modulation scheme used in GSM is GMSK, which is a kind of continuous phase modulation method. GMSK is also a form of modulation used in a large number of digital ratio communication systems. It has the advantage of compromising between spectral efficiency and complexity of the transmitter. Except for GMSK, the basic MSK and OQPSK are two other popular modulation schemes. The choice of digital modulation scheme will significantly affect the characteristics and performance of a communication system. So the objective of this project is just to verify the characteristics of these three digital modulation schemes used. They are GMSK, MSK, and OQPSK. Here we want to introduce these three modulation methods first. First of all, we have the OQPSK modulation methods. So OQPSK, if the 2-bit streams I and Q are offset by a half-bit interval, then the amplitude fluctuations are minimized because the phase will never change by 180 degrees. This modulation scheme is named the offset quadrature phase shifter keying, which is obtained from QPSK by delaying the odd bit stream by a half a bit interval. Here's the formula. Then we have the MSK modulation methods. MSK is obtained from OQPSK by replacing the rectangle pulse in amplitude with a half-cycle sinusoidal pulse. The MSK signal is defined as follows. This is the formula of MSK. The power spectral density has low side lobes that help to control adjacent channel interference. This is a very important improvement compared with QPSK. The last modulation method is GMSK. GMSK is based on MSK modulation methods. We know that a Gaussian-shaped filter generates a signal with low side lobes and narrow main lobe than the rectangle pulse. Since the filter theoretically has output before input, it can also be approximated by a delayed impulse response that has a Gaussian shape. This modulation is just called GMSK. On the other hand, there are two methods used to generate GMSK. One is frequency shift keying modulation, and the other one is quadrature phase shift keying modulation. Both methods lead to the same GMSK modulated signal. After that, we started to build our simulation model. In this project, we use Simulink to build simulation models by dragging blocks from the library browser onto the graphical editor and connecting these blocks to establish the mathematical relationships between them. We can also set up parameters by double-clicking the blocks. Here's an example parameter setting. We have built a simulation model for the GMSK methods. Here we have the input data seeming, a unipolar block converter. Here's the GMSK modulator baseband block, an additive white Gaussian noise block, a GMSK demodulator, as well as an error rate calculation block. we have all the parameter settings here for the GMSK modulator and demodulator block, the AWGN channel, and the error rate calculation block. Now we will do the first experiment, that is the BER performance of GMSK with different BT product. So in order to study how the parameters in GMSK would affect the BER, which is bit error rate, I built a new simulation model as is shown in the next page. And I set the BT product as 0.01, 0.1, and 1 respectively. Here is the simulation model for this experiment. That's the result. As you can see, and the same signal to noise ratio. If the signal is higher BT product value, the BER value will be little, which means it will have the better performance. This is because a larger BT product performs better in terms of BER, for the reason that a smaller value of BT product will lead to greater inter-symbol interference in baseband, which would reduce the BER performance. Our next experiment is the performance comparison between GMSK, MSK, and OQPSK. So we start to compare the quality of these three modulation methods. Similarly, we can set the parameter for MSK and OQPSK just as the way I do for GMSK. Here's the simulation model for these three modulation methods. Here's the result of their quality. So when the BT product is 0.1, we have calculated the beta error rate for different signal to noise ratio. There are altogether 13 of them from 0 to 12, and we can see that almost each time the MSK will performs better than GMSK, and GMSK performs better than OQPSK. So in this way, if we have the BT product as 0.1, MSK would be the best modulation methods for us. Also, we have the signal trajectory constellation and eye diagram block for each of the three methods will give us more information about the quality of these individual modulation methods. Here's for GMSK when the signal to noise ratio is equal to 13. Similar for the MSK methods and the OQPSK methods. Just pay attention that the signal to noise ratio is always 13 at this time. Also, I plot the power density spectrum of the three modulation methods. So as a result, compared with MSK and GMSK, OQPSK has a larger power spectral density but performs the worst in terms of BER. MSK outperforms GMSK in BER, which is probably because the Gaussian filter used in GMSK causes inter-symbol interference. On the other hand, the BER performance of GMSK is related to the value of BT product. So if I change the BT product to 0.3 instead of 0.1, then they will become really near in the performance of BER, and the GMSK will almost be even better than MSK at this time. So as a result, the spectral efficiency of MSK and GMSK is higher than that of OQPSK. Compared with MSK and GMSK, OQPSK has a larger PSD but performs the worst in terms of bit error rate. The third one is MSK outperforms the GMSK in BER, which is probably because the Gaussian filter used in GMSK will bring to us the inter-symbol interference. The last one is if I set different BT product, the performance of GMSK may be even better than MSK. For example, the BT product is equal to 0.3. Then at this time, GMSK becomes our best modulation methods. Okay, that's all. Any question? Thank you. Now I will run the computer programs for you. It's the .m file. Run it. Here we set the simulation time as 15,000. The sample time is 1, and the seeming time is just the input time from 0 to simulation time. The step size is sample time as 1. The second input signal for the OQPSK is from 0 to simulation time as well. Here's the code. Okay, here is the simulation model for MSK, GMSK, and OQPSK. We see the signal to noise ratio will run from 0 to 12, so that's altogether 13 times of this experiment, and each time it will grow from 0 to 50,000 with a step size as 1, so it will run for a while. Now we can see the eyes diagram for each method, the scatter plot scope for MSK, GMSK, and OQPSK, also the signal trajectory scope for these 3 modulation methods here. And we have the power density spectrum for the 3 modulation methods together, which all verify the theory of them well.